The first step in any engineering project is to develop a prototype. Once you've finished with your design work and you've figured out how you want to build things and what the forces involved in the problem are and whether your design will ultimately work on paper, it's time to start putting your ideas to the test.
Testing. Ah!
We want to build a small 1/3 scale model of our idea, just so that we can verify how the parts are going to fit together and whether or not our whole idea behind the fabrication and integration of the vehicle are actually possible. So let's get started. All prototyping starts with the design process. For this, we're using a program called Fusion 360, which is a freely available software for all students. Our plan is to 3D print the main components of our rocket, which include the upper bulkhead, the middle bulkhead, the nozzle, and the nose cone. These pieces will then be fit onto the combustion chamber and the oxidizer tank, as they would be on the real rocket. We chose to 3D print these parts as they have complex geometries. For the real vehicle, we'll actually not be able to do this because 3D printing aluminum is quite expensive. Instead, we'll probably end up CNC milling, which is a reductive process instead of the additive process, which 3D printing is. A 3D printer is basically the magic wand of engineering.
Magic.
Then we were off to the local hardware store for some supplies. We bought some PVC pipe, which we will use for our oxidizer tank and combustion chamber. We also got some acrylic sheet, which we're going to use for our fins, and some glue to attach them. Finally, no rocket is complete without a cool paint job. These are the parts that are going to connect the tubes of the rocket together. And there are some structural supports that are connected in these 3D printed parts, and the finish is kind of rough, so we're sanding that down. And then we've bought some of our tubing, and we've sawed that into the correct dimensions that we want to have. And now we're just sanding some of the parts down and getting the connections to be a little bit tighter.
I don't like sand, and it gets everywhere.
Finally, we had all the parts sanded down so that they would fit nicely with each other. Next up was cutting out the fins. We stenciled out our fin design on the acrylic plates and then cut them with the saw. We then proceeded to glue the fin cutouts onto the combustion chamber. Then the exciting job of painting could begin. The plan is to paint the body of the rocket black to replicate the carbon fiber reinforced plastic color that we'll be using for the real vehicle. And then to paint the bulkhead fittings white in order to replicate the aluminum that they'll be made out of. Unfortunately, we vastly underestimated how long the paint would take to dry, so we decided to shut it down for the day.
One eternity later.
Let's look at some of the outcomes of our prototyping from a couple days ago. Here we have our oxidizer tube. We also have here our combustion chamber. You can also see here that we have our fins attached to the carbon composite combustion chamber. So now the moment of truth, putting the parts together. So here we can put our nozzle on to the bottom of the combustion chamber, so that fits nicely. We can put our middle bulkhead onto the top of the combustion chamber. Putting the oxidizer tank on. I'm going to put this on the ground. Okay, so the oxidizer tank is now slipped onto the top of the middle bulkhead. Then we can put the upper bulkhead on. And then finally the nose cone. And there you have it. That is our rocket.
Beautiful.
Now for the cherry on top. Let's get that ASTRA logo onto the rocket. Making a custom stencil for spray paint is a bit complex. To tackle this problem, we laid down masking tape onto cardboard from a cereal box. We then overlaid our stencil, which we printed, onto that masking tape, and then we cut around the stencil. This had the effect of cutting into the masking tape and allowed us to peel off the masking tape. We then placed the masking tape stencil onto the rocket body. Now for the moment we've all been waiting for. Okay, let's see what this looks like. I'm excited. Looking pretty good.